Hello, Emma. All right, we'll go do congruency and similar. Yes. Okay, you have finished both congruency and similarity, right?
Yeah.
Yeah. Okay. So I just run through some key points. Number one, okay, how to prove congruency? You got to check both the you have two items. Let's say the one image, another image. All the sides are the same, and all the angles are the same. That one is one, and then you know this sign, right? This means
Congruent.
congruent. Okay. So congruent means exact. There's another one which they give you 3 tests. Sometimes you don't know all the sides, sometimes you don't know all the angles, but there's 3 tests. So first test is called reflection. Do you remember? And then you remember the other 2 tests? Reflection, somehow? Remember? Rotation is the next one. And the third one is translation. I'm just going to run through very quickly. So third one, translation. And maybe you know, you see it, you may know, but maybe you might not know the name. So reflection is mirror image. Let's say you have something like this, and then you have a mirror line like that, right? Of course, they don't draw the mirror line. Let's say now so you know that this one is, you can calculate the distance to the mirror is the same, it's the same, it's the same. Then you know this is a reflection. Rotation is when it spins around, right? And another one, translation, means a movement. So this is all there is for congruency. At Sec 2, this is all there is. Oh, sorry. Okay, Sec 2, this all there is for congruency. So the test can be all angles the same, all sides the same, or then you have the 3 tests: reflection, rotation, translation. For similarity, how do you know something is similar? What is the test? Remember? The angles must they be the same? Yes, angles must, because you have small triangle on here and a big triangle, and they are similar. Angles are all, this angle is the same as this. This one same as this. And the third one is the same. That is test number, that is, yeah, if you find all angles are the same, it's correct. The other one is a ratio of sides. Let's say this is 5 cm, this one is 10 cm. So it's 2 times. So down here, if this is 4, let's say this is 7, this one must be 14. And this is 8, this one must be 16. So the ratio with the corresponding sides will be the same. 16 divided by 8 is 2. 14 divided by 7 is 2. 10 divided by 5 is 2. Can you see this proof they are similar? Are we okay? So it's just this 2, and then from there you have so many questions. So anyway, we'll move to this. And can you try question number? This is from the book 9A. And can you try to fill up this one and you tell me what the answers are?
What page is it?
This is page 49 or what? 49. Let me see. Fine. 9A. This is 23. 23. Okay, what are your answers? AB is equals to,
PQ equals 44.
okay, BC equals to,
QR equals 41.
okay, AC equals to,
PR equals 27.
ABC equals to,
PQR equals 37.
BCA equals to,
QRP equals 78.
okay, CAB equals to,
RPQ equals 65.
okay, all your arrangement of the angle names and all they're all perfect lah. So that means you have no issue. So you know that ACB cannot be called QRP, right? It has to be called PRQ. So well done. Okay, so let us try question number 3 lah.
Y equals 97 degrees.
Okay, you mean x equal 97, y equals to
50, no, 32.
32. Okay, so it's easy, yeah. So we jump question. Let us do question number 6 down here. What does your teacher call this? Is it P prime, Q prime, R prime, or theta, or what? Do they call this PQRS? This one will be P.
He only says PQRS.
You just say PQRS also. Some people will call it P prime, Q prime, R prime, S prime. Yeah, but anyway, or theta or something. Question 6.
88.
88, number 6. Well done. Okay, and angle PQR.
Thirty.
30, well done. So it's easy, yeah. So far, yeah. Okay, let us look at others now. That maybe this one. Can we try this one? Question 8.
$98.
Sorry, 98. Well done. Well done. And your angle AEC.
$118.
Well done. That's good. You're fast, huh? Can we just try this one, number 9? The values for x, sorry, of x and y. This is faster. X would be, okay, x, yeah, but never mind. You just tell what the answer is.
15.6.
Okay, and y?
40.
Sorry?
40.
No, cannot be 40. Opposite angles of a parallelogram are equal, right? So this is 63. These three add up 180.
$94.
94. Okay, good. Now, can we try question 10A and 10B? They want you to divide it into congruent shapes, but you do it here. You do it on the screen. Hold on, one moment. You want to do it on your that thing first, no problem, or you can do it straight. Ten A lah, 10A. Okay, 10. Well, that's fast. Huh? What about 10B? So this one you need to use ruler. But they want 3 congruent shapes, not 2. So that is 2. They want 3.
Oh, I know.
Okay, well done. Okay, so we are assuming this is double of this. Okay, not bad. Here we go. I will move to the next one. So similar. All right. You have to now determine whether they are similar or not. We try the first one. Okay. For A first, we do A. Eh? Just hold on. Eh? Okay, remember as we when we for you to find out whether they are, remember the thing here, this is for congruency we are done. The three angles got to be the same. Once the three angles are the same, they are confirmed similar or congruent. Because congruent also all angles are the same, right? So we don't need to measure using a ruler for this one, but we can determine the angle. This, let's say this and this, they are equal right angle. You got to determine whether this now is the same as this. Do you think they're same?
Yeah.
Okay, so let us see. Down here now, we agree this is 90. Now the base down here is the same, you know. The base is same. So now the ratio is 1 to 1, you know. Correct. But the ratio here, this is 2 and this is 3. Can you see that the ratio is like 3 over 2? Then now here's 1 to 1. So it's not consistent. This is out. Not similar. Huh? Remember, there's two ways. One is to check the angle down. No, I mentioned about angle. So how do we know the angle is different? You see down here, this is like 1 unit. 1 unit. Then you go up by 2. You're gonna draw a line like that. When you go up higher down here, can you see that the angle now is going to be different? Oh, let me see here down here. We look at this one. This is 1, 2, 3. So I try to go up here lah. 1, 2, 3 from here. When it goes down here, can you see the angle is slightly more? So we know the angle is not the same. Neither is the ratio the same. So either one. Once you find something to show that, look, the angle is not the same, that's it. It's out. Okay. Now the next one is a little bit more difficult because over here is easy to tell because it's on the straight line down here. You can calculate. You see, you can calculate. The next one, is it the same or not? You can try using your ruler, see does it work with your ruler. If not, we got to use another means. You may need to use a ratio. You can even use your angles if you can find. Well, how has your teacher taught this thing? Has your teacher taught you this like that?
Yeah.
So how does she compare? Does she use a ruler to measure?
Wait, let me check.
Does she remap the thing? My suggestion is do a translation. That means shift this down and see whether it is.
We didn't do a question like this.
Okay. Okay, my suggestion, let's say, Emma, you cannot use ruler lah. You do move this triangle here. Superimpose. You know what superimpose? To put it on top. So this B now, we move 1, 2, 3, right? And then 1, 2. So now B is going to be here. So you count now, B has 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 down here. Okay, and then down here you see it goes 5 squares and go up how many squares? 6. Does it go 5 and 6? You try to draw on your, you draw on your, you know what I'm talking about? To draw this triangle here. Then you'll be able to see, is it really similar or not?
Really?
Sorry, is it similar?
Yes.
Okay, it looks similar, but I'm going to do it now. Down here, watch. Do you agree there's 8 squares here? You agree? No? So 8 squares, this marking is correct. Down here, C. Yeah? And then this goes 5, 6. You agree? Watch. Watch. 1, 2, 3, 4, 5. Then up 6. 1, 2, 3, 4, 5, 6. Oh, can you see the angle is slightly out? No. The angle is slightly out. Do you get something like that? Okay, you know how to calculate this one. Down here, you count the horizontal movements. Down here, you have 5 small squares, and then 6 squares up. So from this point B, let's say we put it down here, right? So we got to go 5 and 6. You know what I mean? Can you try? You will get a different angle. By superimposing it, you can see whether the angles are the same or not. How do you get it? Going out?
Yeah.
So when you superimpose, you can see, because from your naked eye, you cannot see, it looks the same, But then we can see how many degrees off. The other thing, if you draw the line straight, if it's truly similar, you'll be parallel. The angles will be, let's say something like this. If let's say you got another smaller triangle, you feed it. It will be, these two will be parallel. The angles all the same. But down here, we know that the angle is already off already. It's wider. This has a wider angle than the bottom. So this is not, this is not, you get it, So you can use a superimposing of this. The movement we are doing now is called what? It's called translation. Okay, that means what's translation? You see, I'm going to shift this down. 1 big square, 2 big square, 3 big square, 2 small squares.
My teacher didn't teach us this.
How do your teacher teach?
She didn't, he didn't
Cover it all.
Yeah, didn't teach translation.
Translation. Okay. Translations for congruent. So did not teach. Okay. Never mind. Never mind. Okay. Didn't teach. Then never mind. We cover more ground. It's okay. Because actually at Sec 3, you got even more to learn about the congruency and all. But anyway, let us see now. Okay, we try A first. Do you think is similar? They're asking you, is this similar for question A? You use a ratio. You know the ratio method? Take the bigger one, divide by the smaller one. Corresponding, it has to correspond. You see whether ratio is the same.
I divide it.
You divide. Are they the same? Okay, we try. You tell me now what's the answer. AC divided by PR. We are assuming AC and PR are the same lah. What do you? 1.5. Good. Okay. Then we have hold on. A what? AR. AR divided by PQ.
$1.5.
1.5. So far looks good. So far looks good. But all three got to be same. Next one, 63 divided by the last one. RC BC divided by QR.
1. It's a very long decimal.
Okay, so that means it's not the same. This is not similar. Okay, proven not similar. Why? The ratio got to be same for all corresponding sides. You see what? If the polygon got 20 sides, you can test all 20 of them. So long as one is out, that's it. Don't need to do. You get it? Let's say the first one you did. Your first one, oh yeah. First one you won't know. Is the second one onwards, then you'll know whether they're the same. Okay, we move on to the next one. What about, so far none are similar. Maybe this one might be similar lah. Do you think they're similar? Question B. But you got to determine what is corresponding to what. I think quite easy lah. Isosceles triangle, right?
Not the same.
Not the same. Okay. 8 divided by 6, what do you get?
1.3333.
Okay. That's this. Then, so this is 8 divided by 6, so it's the same now. Last one. 5.7 divided by 4.3.
1.3.
Is it the same answer?
Wait, no, it's a long decimal.
But is it the same as the earlier answer?
Kind of.
Kind of. We must be accurate. Cannot kind of. You try again. 8 divided by 6. You look at the answer carefully again.
1.3333.
Okay, 1.3333. 5.7 divided by 4.3. Oh, 1.3255. So
Yeah.
it's different. It's different. So the book says it's the same. The book says it's similar. So the book is not correct. But let us check. Let us check the other way. Okay, let's assume that there's a mistake. Let's try now angles. What's the angle on here? Can you check these two angles? Because it's isosceles supposed to be the same. This isosceles also supposed to be same. Do you have 69, 69 and
Yeah.
same? So we have a problem here. By length, it is not similar, but by angles it's similar. So where does the fault lies? The fault lies in the writing of the book. Okay. Okay, that means we are supposed to change this number lah. So what to change? Just now you said the answer is 1.33333, right? Can you take 4.3 times 1.33333 or 1 and 1/3? Can you use 1 and 1/3 times 4.3? How much do you get?
5.73333.
Okay, down here. Okay, now I need a favor from you. You write into the textbook publisher and tell them this is supposed to be the correct reading. Will you do it? Okay, but you understand what I'm telling you, huh?
Yeah.
Okay, you take one length over the other length, the ratio got to be consistent. Then it's similar. Okay. If the ratio is 1, that means it's congruent. No? Okay. Yeah, that one I'm sure you know lah. Okay, they give you 6, 6, 6, 6, 4.3, 4.3, you know it's congruent already. Anyway. How long ago did your teacher started on this one?
Yeah.
Today. Okay. All right, we try this one. They already make the statement now here. Okay, Emma. So you must look at what the statement says. They are not asking you to prove, but they tell you that ABC is similar to PQR. They have already told you. So you got to accept that it is similar. And then from there, you determine what is what.
QPR.
QPR is equal to BAC. Okay, well done. All right. Value of X?
3 cm.
3 cm. Okay. Value of Y? Hey, are you sure 3 cm cannot be 3? Not congruent, no? It's not congruent. This is similar. What's the ratio? 8 and 4.
Wait, I know the one.
Are you stuck, Emma?
No.
Okay. You're stuck, is it?
2.
Oh, 2. Well done. Okay, then you can find out now what is X. You just put like that. So the ratio is 2. That means 8 divided by 2, you get 4. 4 times 2, you get 8. So down here will be, you see, 8 divided by 2 get 4. 4 times 2 get 8. So you need to times to the bigger one, divide to the smaller one. I'm talking too fast. Okay, down here.
My teacher taught a different method.
What is the method? Okay, your teacher taught you this. 8 over 4 is equals to X over 3. Am I correct?
No.
Okay, what method your teacher taught?
It's like AB.
Okay.
Wait.
AC over P.
AB over PQ,
Mhm.
then BC over QR,
Okay, yes.
then
It's the same thing. Okay, so what does it mean? What does it mean? Huh? So now I'm just teaching you the gist of it. This is the most important part. So A, B is 10 over Y. This must get 2 also. Because they tell you that this and this is the same, right? A is equals to AC over PR, correct? And then it's equals to BC over QR. Your teacher taught you something there? It's the same thing. What
It's
is
like
this?
he lists down the like BC over QR whatever. Then he'll like see which one what numbers are already there. Then he'll use that as a formula.
Okay. You have the notes there? Can you just take a photo of that part and then I analyze it? Okay, you've just sent a photo. Okay. Now I'm gonna share this one, right? So okay, so what this is actually the ratio lah. PQ over ST. This is a ratio. This ratio, if both are similar, they're similar, and the statement says it's similar, the ratio will be same, consistent with QR over TU, which you will get 2, right? So your teacher has shown you this method. Now, this is a complex way of doing it, which is okay. Okay, don't worry. It's no problem. You want to have the complex way of doing it, I'm going to give you the complex way of doing it, okay? But you agree if, let's say, I put down here X, now ST, yeah? I can put X here. And then ST is here. So I can put 15 number. Right now. And then QR is 8 over 4. Yeah, correct. Eh? And then PR is 17 over, we don't know why. But we do know that down here is, let us test whether we get the same answers as here. Okay. So now you have 1, 8 and 4. If 8 divided by 4, you get 2, you know. So from big going to small, you divide by 2. So 8 divided by 2, you get 4. 4 times 2, you get 8. Then let's try this one. You want to find y? 17 divided by 2. Use your calculator. 17 divided by 2.
8.5.
There, down here. Can see now. Now down here, 15 divided by 2.
7.5.
They're here. So now, if you want to use this method, no problem. This is actually the similar method, but what I'm taking is the most important point. What is the most important point? Is there is a scale, you know, a number to times or divide, which is the based on the ratio. See, 8 divided by 4 give me the number 2. So 2 means it's very important. Why? To go from small to big, I need to times 2. To go from big to small, I divide by 2. I'm using the ratio that your teacher taught. Only thing he has written it this way. He's written quite complex on here. This down here is half. Right? If you reduce, it's half. So if I want to find ST, I must divide 15 by 2, I get 7.5. What? You get what I'm saying now? Down here now, 8. Okay, why you don't know why, right? 8 divided by 2 get 4. So 17 divided by 2 get, you see, it's the same thing. Only thing now, when you are moving around, it becomes an algebraic. It's quite complex, lah. You know what I mean, but you don't feel safe, You don't feel safe. You don't feel safe. Okay, I leave it. I don't know. We can use that method, no problem, No problem. Okay, now, okay. So I'm going to use your method. Okay, you agree 8 divided by 4, right? And then you want to find the other one is 10 over y, like that. Okay, you solve it, You solve it. You find, because you want to find y, right? Same method, right? Like that. You find y, and same thing. X also, I'm going to just write it for you. X over 3 x over 2, then x over 3, is equals to 8 over 4. Can also, you can use, no problem. But you'll find that you're making yourself, it's like you're going to walk to the market, but on one leg, no? It's okay. So don't say that about my teacher. I'm not complaining about teacher. I'm just telling you, I'm just telling you, it's an okay method. Can do or not?
Y equals to 5.
Y equals to 5. Hey, Emma, look at this. 10 divided by 2, 5. Okay, this other one. This other one. No, because I'm using this ratio. No, I'm using this ratio still. I'm not running away from the method. The main point of the method is you got to use the ratio.
My actually suggested about the divide by 2 thing, but then my teacher insisted on doing this.
Oh, you're crazy, your teacher. You know, the method that you just show, you know how many students are going to get confused by this part. I'll show you. You know this part, you know how many students do not know what to do? And then down here, let's say you have the X at the bottom, they need to learn how to flip. You know, there's going to be so many students in your class that they say, hey, teacher, what to do? So the teacher will tell you like this. Okay, I'll show you this now the method. Okay, so now we got to get rid of 15. We times 15 down here. And then we times 15 down here. Wow, you know what I mean? It's just a whole long process. No, it's like telling you, okay, you can go to market, but you cannot take shortest path. You must walk one round, go around the school and on and come back. Can also, but for your test, I suggest do what's logical. Am I teaching you what's logical? But you see your some students ask your teacher, say no.
Yeah, my teacher said that you shouldn't assume.
Oh, okay, I can tell you why. Okay, that is very, very correct. If there is no such statement here, now the question already says triangle this one is similar to triangle 2. Am I going to doubt it? In fact, you look at the question you just showed me. In the question you showed me down here, your teacher also says, or the question says that triangle this is similar to this. I'm not going to doubt it. But if they did not tell me, that it's similar, I should use that method. Because why? I'm testing out to see whether the ratio is consistent or not. Just like what we did earlier, remember now? We checked 1.5, 1.5, and then 1 point something, though we know it's not similar. But if the question already says it's similar, why do I want to waste time to prove it again? You know what I'm talking about? So maybe your teacher has had experience when the teachers teaches this method using the ratio 2. Some of those students who are careless, they just assume. Like just now, remember we did the 1.5 thing, but it's not similar. So that is my conclusion, and trust me, it is true lah. I'm not telling you a bluff thing. If you think it's logical, great lah. If not, they see down here. Once I tell you similar, okay, I can see your teacher's point. Okay, let's say, okay, Emma says, let's say Emma, we use this lah. Okay, your teacher says, okay, don't assume. So from 4 to 3, 4 divided by 3, you get 1.33333, right? 1 1/3 lah. Then I told you, from bigger to smaller, you must divide by 1.3. So you divide by 1.1 1/3. And then you write the answer here. Sekali is wrong. You know why? Because this may be the wrong side. Maybe this is similar to this. Maybe. So there is truth in that. But if you are very, very clear, if you are very, very clear which side is similar to which, then it is more or less safe. Normally, if they tell you this is similar to this, okay, you know that these two are the angles are the same, right? And then AB for, so we are talking about DE, the next two, see, DE. So this is similar to this. You know what I mean? Then BC here is similar to EF 5. So we know which is similar to what, actually even by the name of it. But okay, you do what you feel is like. No, I know it's a cliche saying. They say follow your heart, but this normally comes to emotional stuff and all that. But yeah, but I leave it to you. Okay, I've already explained to you very clearly. If they give you this, you can assume for as long as you don't make the mistake thinking, oh, this is similar to down here. Abela. You know what I mean? Let's say now, some students say, yeah, my tuition suggested. So yeah, this one is similar to, of course you will get it wrong now, because is the wrong side you are taking it similar to, see? You know what I'm talking about? Okay. Do not pressure the student. Let her try now. Okay, you try this one. You can use your method, doesn't matter. Hi, Ma.
I'm a bit confused.
Okay, which one method are you using? Your teacher's method?
Yeah.
Why don't you use the method I suggest?
I don't remember what your method was.
My suggestion is okay. Which two lines are similar? Okay, AB is similar to what?
G.
Okay, so you find what's the ratio lah. Take the bigger number, divide by smaller number. 75 divided by 50. What do you get? 1.5, right? So that means 50 times 1.5 will give you 75. Let us try. Yeah. Can you try 28 times 1.5? What do you get?
42.
Yeah. But the thing now is EF is similar to which part? BC or AD?
AD.
AD is similar to this one. Then we have a problem we cannot find. Let us see. Let's see. We do this way. Emma, watch. AB. This is AB. Is similar to GF. GF. I use another color now. Orange. Then the next one, BC. BC is similar to FE. FE. Can you see how I do? So you know these two are related. If it's going to go to the smaller one, you use 1.5, but just divide. She is very scared of using the wrong method, not endorsed by teacher. It's okay, it's okay, that's good, that's good, that's good. But sometimes you must remember the teacher is teaching a whole class, and in the class they are very careful. It's like, every time you go into the toilet, you're going to check, is the woman sign there, and then you check inside, is it actually a woman, then you do, but if let's say you have gone to your school often, the left is women's, after a while you don't check. However, your teacher is right once in a million times, maybe you can get it wrong. And I came from a school called Yishun Junior College. There was actually a case of rape actually in the school when I was a student. And then what the principal or whoever did, they go and change the girls' toilet to the boys' toilet, and the boys' toilet, and it caused lots of confusion because the girls were entering the boys' toilet. So in that case, yeah, you need to check. You need to check. But yeah, so okay, so down here now, you know that this is related to this. How? Just from the writing now here. So we look at the next one now. Which one? So next one is CD. I'm using green. CD is here. So CD is similar to EH. EH is here. So the balanced one that is not represented is HG, must therefore be similar to AD. Can you see how I do it? I'm using the letters now. The first two letters must be similar to the first two letters here. Second two letters should be similar, unless they made a mistake right down here. You know what to do, Emma?
So it's 48 over X equals.
Yeah, to yes, equals to 1.5 or equals to 75 over 50 lah. Either one. Correct. Okay, use that method. Yes, use that method.
$72.
32 or 72?
72.
32,
72.
72. Hold on. Oh yeah. 72 lah. Come get 72. Let me see. Hold on. Question number 5.
Oh no, 32.
32, right? Okay. What about the next one?
21.333.
But remember, you are now going from small to big, you know. How come your answer is smaller? Y becomes smaller. So let us see, do you put y over 30 is equals to 75 over 50 or something like that?
Put 32 over y equals 1.5.
32 over y. But if you say 32 over y, you're saying x is 32, no? Right? Means yes, these two are, this is green, right? It's orange. They're not similar. There's now 48 was similar to EF. So okay, so we do it this way. Let us be very clear on here. Down here now we have I'm gonna clear that. So you have A, B. Normally, yeah, you can use this, okay? A, B, and CD, and then G, F, E, H. Yeah? You see, you notice or not? They didn't. You see down here is alphabetical order A, B, C, D. Why didn't they say E, F, G, H? They make sure that it's G and F, E, H. It's a very strict. They should be saying E, F, G, H, right? But they don't do that because they are making sure to tell you that point A is similar to point G. Point B is similar to point F. Point C is similar to point E. Point D is similar to point H. That's why if you remember when you do congruent, if let's say it's A, B, C, remember, and then the first thing I said your arrangement of letters was good. That means you actually gave the correct points of similarity or congruency. So now what do we do now? Okay, so to identify EF here, this is FE here. Can you see? EF, it is similar to BC. See, EF, BC. From the lettering, you can know. Unless your teacher really made a mistake, then you got to be very, very careful.
So 30 over y equals.
Depending, okay, y over 30, right? You're going to make the bigger one over the smaller one, right? Y over 30 is equals to, or you want to use 30 y can, but you must flip the other one. Flip, you know what I mean, right? Y over 30, I'm taking the bigger one over the smaller one is equals to, let's say, what? 75 over what? 50. But if you're going to put 30 over y, can. But remember to put the 50 on top. Why? Because you are taking smaller to bigger. So your next ratio must be smaller to bigger. Again, sorry?
20.
20, yeah. But I think you did it wrongly somewhere. Because this is bigger, no? Why, right? Bigger, no? So let us okay, what's your working? Y over 30 is equals to
75 over 50.
75 over 50. Okay. So now we times by 30 here. You get rid. Also do the same thing down here, times by 30. You try.
I flip both sides.
You want both sides.
I flip both
Flip.
sides.
But you flip both sides, your y become opposite, you know. Let's say you do y over 30. You flip and become 30 over y, you know. Then it becomes 50. Okay, this one 75 or 50. When you flip, you don't need to flip actually. If you flip, it becomes 50 over 75. Now it's already on top. If you want, what you can do is this. Okay, if you want, you just bring the 30 over that side. So let's try this way. So you bring 30 over that side, push it up the seesaw. So you comes 75 times 30. This one disappears from here. Because the y is on top, is y over 1 now, which is what you want to find. What you may find now, 1 over y is complex. You need to flip. But this is not, the y is not below. See, this is what I mean when your teacher teach you this method, the student needs to be very, very precise in the algebraic manipulation here. No? So, but no problem. So down here, you have now 30 at the bottom. So you, to get rid of 30, you've got to times both sides by 30 lah. So you cancel, and then times by 30 here. That's the way to do it. Then you will get, let me see. I think 40 is 45, is it? 45, yeah. Are you okay? I feel like your teacher is putting you all through a, never mind, that's your school. I better not get into. Okay, this one seems to be, yeah, this is, yeah. Can you try this? Can Emma?
31.5.
Well done. And why?
31.5.
31.5. Down here is 31.5, right? But why? Same also. Okay, so let us okay. The ratio that you get 28, or you took the longer over the shorter, or shorter over longer? 28
Long over short.
longer over shorter. So you took 42 over 28 lah. Right? So you will get down here, this is actually 1.5. Right? So notice, can you notice the pattern? Now I'm gonna, so mathematics is not just about formulas, no. We can also see other patterns. Emma, do you realize that this now is double of this? You realize 14 times 2 is 28. Your answer down here is 31 times 5, right? Now this one you cannot compare. You know why? Because down here now, this is the whole length. The whole length. But when it comes to, okay, now we go whole length. We go whole length, 1.5. That means this is 0.5 units. This is 1 unit. Or this is X, if you like. This is half X. So this is Y. This is half Y. Can you see now? If this is Y, this is half Y, how do I get back to Y? I times 2, I get 42. If you don't believe on here, see, I times 2, I get back there. But okay, that is a creative way of doing it. Okay, let's say you don't want a creative way, how to do this? Okay, so there's now you take 28 plus 14, 42 over 14. Sorry, over 28 is equals to Y plus 21. You must remember that over Y. Do you agree now, first? This whole agree. Okay. So now you can do seesaw. If you believe in seesaw, understand seesaw, you can go up, bring this up here, you get 42Y. And then you can bring this up here, you get 28 bracket 28 times Y plus 21. If you're confused by this, we can do another method, no problem. But this is the fastest method. Are you confused by this method? No. So now you get 28Y plus 21 times 28. How much is that?
588.
All right. 588. Okay.
Y equals 42.
42. You see, okay. So now I'm just worried. You shouldn't. I fear you are afraid. So you must remember that being confident. Of course, we can be overconfident. Be confident. We trust that we are intelligent enough to use a strategy and get the answer. And then as we somehow as we experiment with the question, we realize there are some faster ways, for example, of getting the answer. Then we test it. Does it work all the time? If it works all the time, you must be confident that it works. Like, for example, the seesaw method. You see, I don't think this is taught in school. You bring this over here, bring it, it's equal. But it works. In fact, it's actually a very shortcut. I cut several steps to go there straight. So the thing is, yeah, no problem following the formula, but you just got to bear with the patience of following step by step by step by step by step until you reach. No issue, no issue. Okay, so you got this one, well done. A similar one.
X equals 4.9.
X equals to 4.9. Sorry, QC, is it?
Yeah.
QC equals to 4.9. Okay, the different answer from the book. So do you have your working with you? Can you show me your working so that I can check? You can either show me or I can. Okay, wait. Okay, thanks. Okay. Let's see this. Okay, maybe I'll share. Let me share screen so that you can see everything and you can see my messy. Okay. So let us see now. Okay, so you are calling this X, correct? Am I correct to say this is X, QC is X?
Yeah.
Yes? Okay, so now, down here, am I watcher? This is BC is correct, 16. 16 over this PQ, you know? Correct, 7. So yours should be AC over AQ because this is the original one. Right? This is the original triangle. This length should be at the bottom, 6.3. On top is x plus 6.3. You get it? Not? You don't get it. You don't get it. You don't get it. Okay. Now, why is it wrong? Because now, when you do it, I show you now. I draw the two triangle. Look, look. This is what you are doing now. Now, you are just taking the bottom part, like a skirt like that. You are saying that this divide by this, but you look at the two shapes. Are they the same? Not the same. You must take this divide by this one here. They are similar. Can you see? It's a triangle. This is a trapezium. Huh? Can you see now? This must be divided by this. Are you okay? So it must be divided by 6.3, not x. Huh?
8.1.
8.1. Well done. And the other one is AP. Or maybe you got to work AP lah. You try getting it.
Nothing is wrong.
You think it's wrong? Can you show me again? Is the down here answer key has double decimal lah. Yeah, you're right. You got it correct. 8 point. I think you got it correct. 8.48 is correct.
Because the calculator showed 8.477777.
Yeah, so correct. 8.48 is correct. So all right. Yeah, that is to the probably nearest. Yeah, they should have written lah to the nearest whatever. So you got it right. Well done, Emma. Okay. This one, okay, it's an interesting one. Okay, they are similar cuboids. Can we try this one? I think by the end of this question or so, you are ready for congruent and similarity. Okay. Next topic, what do you want to cover? Have you done map skills? Have I done map skills with you? Map skills. No, there's the next topic actually. Right after similarity will be map skills. So if you feel you're confident enough with this, the next session we do map skills. If you're okay. So if you find a never-ending ratio number, you may want to leave it as a fraction so that it doesn't convert to the nearest whatever, is it, to ensure accuracy. So I got a ratio, simplest form is 21/17. That's my simplest formula. So I'm going to use that ratio. The number is, you can put it to the nearest 2 decimal place.
70/221.
Sorry, 70/221.
221. 221.
70/221. Okay, can you show me again? Can you show me? Show me your working number. Okay, thank you. Okay, so let's see. Yeah, this is it, right? Yeah. So you have taken 8.4. This is where the mistake is. You have taken one side is the bigger one. 8.4/6.8. Which one is bigger? 8.4 is bigger over 6.8. Then you see it's equal to smaller over 3. Habis lah. That's it lah. Once you take the smaller, you know what I mean? This side now, okay, this side is smaller, you know. If you want to take smaller over bigger, you must take smaller over bigger. That means you should do like that. X over 3.9 is equal to smaller 6.8 over 8.4. You will get it. You know your mistake, Emma? You know what I'm talking about, huh? Because this one puts it in chaos, you know. Come on.
311 over 70.
Okay, well done. 311 over 70. And the other one, please.
How do I know whether to put 6.8 at the top or bottom?
Okay, so now what you want to find? Okay, your first ratio is what? Is it y over 1.4 or 1.4 over y?
Y over 1.4.
Okay, so you are putting the bigger one because this is clearly bigger, right? This whole thing is bigger. It's bigger over smaller. So you must also we must put the bigger 8.4 on top and 6.8 below. You must be consistent because this divide by this is the same as this divide by this. Are you okay? Why you look so stressed, Edma? Are you stressed up, man? Cool, take it easy, okay?
One 62 over 85.
Okay, well done. You can do it. You just need to be careful only. All right, that's it. Okay, see you. You take care. Bye-bye.